Kerbal-made probe explores the Kerbal system. Early this morning, the KSA prepped and fueled a rocket to be sent across the depths of interplanetary space on a month-long journey to the mysterious planet of Duna. The Duna Communications Lab will be sent up to observe the red planet and its large moon up close, as to confirm or deny if the planet is made entirely of Kerbal pepper. The red dot seen in the sky will now gain a distinct identity as the KSA plans to capture the very first images of this body from deep space.
Hello everyone, this is Shimmy, and I'm back with some more Kerbal Space Program, playing the Sandbox Space Campaign, and today we are going to be doing our first interplanetary mission. We are going to be sending a probe to Duna. So, basically, how it's going to go, I'm going to go ahead and do a launch. Don't need to do any waiting or anything, and just plan and go ahead and get there. Probably going to be a couple, probably two-parter, because I plan on sending this guy past Duna and past its moon Ike, in order to get, more mission money. Either way, the thing about sending a probe to another planet opposed to a moon is it requires a lot of patience. Specifically, you need the planets, not metaphorically, but to literally align properly before you can launch there. Now, luckily for me, just the way that this entire thing, the entire campaign has gone so far, it's already aligned. I'm using Flight Engineer here. The current phase angle, or the angle as it is in reference to the sun, I guess if you put a protractor on the screen here, the angle between Kerbal and Duna is actually pretty much perfect. Maybe it might be a couple days ahead of, after when I want to launch, but that's perfectly fine. This is definitely going to be, it's definitely going to let me launch and get really, really close to Duna. So instead of waiting an entire year, or actually longer, for this perfect alignment to happen, I'm going to go ahead and launch right now. So I didn't have to be patient. I just had to launch at the right time, or just play the game, and it happened. Also, another thing here, if you don't recognize this engine, this is one of the KW rocketry engines. As I had mentioned probably in a few episodes before, about how there aren't any middle ground rocket engines. Well, this one is one of those. It has a thrust of 120 opposed to 220 or 50. So it was a good rocket, good engine for right in the middle. Either way, I'm going to go ahead and launch, get into orbit, and plan the escape trajectory in order to go for Duna. So wish me luck here, and here we go. Alrighty, I am here in orbit now, in a roughly circular 100-kilometer orbit, and I am now going to go ahead and plan for my escape trajectory here. Now, I had originally planned to explain the entire process of waiting and all that, but unfortunately, conditions were perfect for my launch time. I did not plan anything like that, it just kind of happened. And if you see here, the angle between Kerbal and Duna is roughly 45 or 44 degrees. That's actually what you're looking for when you want to head to Duna. Now, all the planets have different angles that you want to launch at in order to get there at the right time. For Duna, it's about 44 degrees. The flight engineer does provide you that actual information. It gives you that information in your current phase angle, which tells you the degree. between each, and the intercept angle actually tells you, and when this is 0 here, this actually tells you that it's time to launch. So if you were not at the right time, you would just speed up time and wait for the planets to orbit and get that into the right time. So anyway, now we need to plan for our ejection maneuver. And what we're going to do here, we're going to need to orbit at least once, but as it goes, we need to create a maneuver about here. This, at this point, is we're kind of eyeballing it. And we'll adjust it accordingly. And I believe I've already added too much thrust to that. Yeah, actually, see how close that is already? That's actually really, really close. But I want to get closer and make sure that I'm ejecting at the right angle. So, actually, you can see it here on screen. If you look all the way across the solar system, it actually tells you our closest approach. And if I... can't see it. It's blocked by the sun. But if I adjust this right here, yeah, we actually got a maneuver. Or an encounter, rather. Now, I don't know if that's the most efficient. I would say that is good enough, because we're going to be able to work with that. Everything else at this point is just burning and going there, but the most efficient maneuver would have you leaving Kerbin's sphere of influence, an imaginary sphere of where the gravity between Kerbin and its sun are equal to each other. When it leaves a sphere of influence, you'd actually want to be going in a prograde direction and not kind of in this wonky direction. But that's okay. It's not too bad or anything like that. We're definitely going to get there. So, all we need to do now is just go ahead and speed up time and wait for a maneuver. Now, let's see here. If we go back to our vessel here, we have a tad bit of delta V still left in our second stage, so I'm just going to go ahead and leave it attached for now. Just go ahead and orient towards the maneuver crosshair here and speed up time. And one other thing I want to make sure I do, I need to make sure that my satellites that I launched in the last episode are communicating with this satellite. So right now I just have it communicating using the relay dipole antennas that only go, so far, but I want to make sure that the long-range dish is set up properly. So I'm going to want to choose one of these satellites to communicate with, and I'm going to choose actually the interplanetary ComSat East is the one I want to communicate with right now, so I'm going to go ahead and do that and choose East, save and close. And then I'm going to want to choose in here, I want to make sure both of those are communicating with us or always pointed at it. So we'll go ahead and do that right now. So East, its first dish pointed at the current probe here, the Duna Com Lab. Yep, that's good. And I'll do the other one, Duna Com Lab. So both of these should be pointed at the right thing. Now, just to be absolutely redundant here, I'm going to point its secondary dish at Duna, because once we've entered in the sphere of influence of Duna, it doesn't need to be configured to point directly at the satellite. It can just be pointed at Duna and the communication still works. And the same goes for this satellite. If it's pointed back at Kerbal, then it still works. So I believe I got that all taken care of. All the satellites are, all the dishes are activated. So I believe I can just go ahead and speed up time again. And get ready for ejection maneuver. So let's just go ahead and speed up time again. Says the burn's only going to take 33 seconds. However, the thrust to weight ratio, or the amount of thrust in this engine, is way larger than in this engine. So I'm going to want to do it a tad bit early because it's going to take longer than 33 seconds. Alright, I'm going to go ahead and do it at 44 seconds here. Give that a good start. Definitely a good push. We're going to go ahead and decouple and activate it. And see how it says it's now an estimated burn of 1 minute and 10 seconds. So I might have done that a tad bit earlier, but that's okay. That's all right. I did launch this probe into a higher orbit, so it would have less time to well, not less time. It will be orbiting Kerbal at a slower rate, so the issue where burns take longer is less of an issue. However, that does cause some issues. Well, I wouldn't say issues, but it does cause you to lose the advantage of being as close as possible to Kerbal. It's called the Oberth maneuver, or not the Oberth maneuver, but the Oberth effect, in which the closer you are to the planet that you are exiting from, the more efficient it is when you are doing your maneuver. Alrighty, so I'm going to go ahead and slow this down here. I want to make sure that I don't miss the opportunity here. Alrighty, perfect. So a perfect trajectory would have the apoapsis not be any farther out than Duna's orbit, but this is fine. This is fine. You know, I'm not going for utter perfection here. I want to make sure it's successful, because the way just all this works, you know, I don't want to be fussing with it all the time. So anyway, here we are. We are on a interplanetary trajectory towards Duna, and if everything goes right, then we should be entering Duna's gravitational field after about 52 days. So anyway, I'm just going to go ahead and speed up here and see if that happens. And hope and pray that my satellite dishes work how they should. Because if they don't, then can have a bit of a problem. The launch for this vessel costs about $50,000. But I believe the missions that I'm going to be doing with this are definitely going to make up for that. So anyway, still communicating. The fact that it's still communicating at this moment tells me that I did it correctly. All my different satellites just relaying. Pretty neat. Alrighty, here we go. And just going to want to double check, make sure this is still pointed at the right thing. As it crosses the boundary here, I don't want it to lose contact.